Assistant Professor, Department of Science and Humanity, Emmanuel Arasar JJ College of Engineering, Nattalam. My topic, Mathematical Logic. In this chapter, we shall study the mathematical logic, which is included with all kinds of reasoning. Mathematical logic has two aspects. On one hand, it is analytical theory of art of reasoning whose goal is systemized and codify principle of valid reasoning. It may be used to judge the correctness of statements which make up the chain. In the aspect, logic may be called classical mathematical logic. Second one is the other aspect of mathematical logic is interrelated with the problems relating the foundation of mathematics. First definition is statement. A statement is a declarative sentence which is either true or false but not both. The capital T is truth or falsity of a statement is called its truth value. The truth value is true and false. True is denoted by T and false is denoted by F. It is also denoted by then true is 1 and 0 is false. Then example, Bangalore is in India. It is a true sentence. It is called the statement. Then example 2, then statement P from 5 greater than 8. And this statement is a false statement. Then example 3, Q statement from 5 greater than 3. This statement is true statement. Then PQR, it is denoted by statement. Connectives and compound statements. Statements can be connected by words like not, and, or. These words are known as logical connectives. Then not, and, or. The statements which do not contain any of the connectives are called atomic statements or symbol statements. Then next is a compound statement. A statement that is formed from atomic statements through use of sentential connectives is called a compound statement. Then example of common connective words are negation. Then negation is a negation symbol, and symbol, and or symbol, if then symbol, if and only if symbol, then equivalence symbol. We will use these connectives along with the symbols combine various symbol statements. Then truth table. First one is conjunction. A compound statement obtained by combining two symbol statements. Then say P and Q by using the connective word is and is called the conjunction. That is, the conjunction of two statements P and Q is the statement, then symbol P and Q. Then it is read as P and Q. Then conjunction symbol is a and symbol. Truth table for conjunction. PQ are two statements, then PQ, then first, then true, true. Then second statement P is true, Q is false. Then third one P is false, Q is true. Fourth one is P is false, Q is false. Then four possibles are given there. Then last columns write the P and Q truth values. Then P is true, Q is true, P and Q is true. Then P is true, Q is false, P and Q is false. Then P is false, Q is true, then P and Q is false. P is false, Q is false, P and Q is false. This table is a conjunction truth table. Next one is disjunction. Any two simple statements can be combined by the connective or. Then disjunction, connective word is or. To form a simple statement is called the disjunction of the statements. That we take two statements P and Q. Then they write the disjunction form is P or Q. It is read as P or Q. Then that is disjunction of P and Q. The disjunction of P and Q is denoted symbolically by P or Q. Then it is read as P or Q. Next, truth table for disjunction. Then P and Q truth value is right there. Then first one is P is true, Q is true. P is true, Q is false. P is false, Q is true. Then P and Q are false. The last column value is P or Q value. P is true, Q is true, P or Q is true. Then P is true, Q is false, P or Q is true. P is false, Q is true, P or Q is true. P is false, Q is false, P or Q is false. This table is a disjunction truth table. Negation. Let P be any simple statement. Then the negation of P is formed by writing it is false that before P. The negation of P is also obtained by writing P is false. The negation of P is denoted by the symbol negation P, or other symbol is then negation P. Then truth table of negation is P is true, negation P is false. Then P is false, negation P is true. This is a negation truth table. This is a negation means not. Then example, let P be Mark is rich. Then other statement Q, Mark is happy. Write each of the following in symbolic form. Then first one, Mark is poor but happy. Then first example, Mark is poor but happy. Then P statement, Mark is rich. Then first one example, Mark is poor. Then rich opposite poor. Then not value, not rich means poor. Then P statement is Mark is rich. That is Mark is poor. The statement is negation P but happy. Then Q statement is happy. Then happy means Q statement. Then first one symbol is negation P and happy. Then second example, Mark is neither rich nor happy. Then neither rich nor happy. Then not rich, not happy. Then rich is P statement, happy is Q statement. Not rich means negation P, not happy means negation Q. That is second example symbol is negation P and negation Q. Then is a conjunction. Then third example, Mark is either rich or happy. Mark is either rich or happy. Then Mark is rich. Then P statement. Then Mark is either. Then one is a true, one is a false. Then Mark is rich. Then other one statement, Mark is not happy. Then Mark is not rich and or Mark is happy. Then I will choose Mark is rich. Then P statement. Then or. Then statement is included the connective word is or. Then or symbol. Then Mark is rich but not Mark is not happy. Then not happy means negation Q. Then statement is P or negation Q. Then fourth example, Mark is either poor or else. He is both rich and happy. Mark is either means then one is true, other one is false. Then Mark is either poor. Then first statement P, Mark is rich. Then Mark is poor means then statement is negation P. Then conjunction word, then and, then conjunction word is a disjunction, then or symbol, then or, then he is both rich and happy. Then rich statement is P, happy statement is Q. Then connective word is a and. Then P and negation Q. Construct truth tables for the following. Then first one is negation of P or Q. Then first table, then two statements are given there, P, Q. Then first write the truth value of P or Q. Then last the full statement negation P or Q. Then P, Q truth values write that true, 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 false, false, true, false, false. Then P or Q, R means disjunction. Then true, true, true. Then true, false, true. False, true, true. False, false, false. Then next last column negation of P or Q. Then negation means then opposite true, false. Then true, false, true, false, false, true. Second example is negation P or negation Q. Then PQ statements, then next column negation Q, next P or negation Q, then last column negation P or negation Q. Then PQ truth values write that true, 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 false, false, true, false, false. Then negation Q, Q is true, negation Q is false. Then Q is false, negation Q is true. Then Q is true, negation Q is false. Then Q is false, negation Q is true. And then next column write the values of P or negation Q. Then P is true, negation Q is false. Then truth value is true. Then true or true, then value is true. False or false, then value is false. Then false or true, then the truth value is true. Then last, then final column value is negation of P or negation Q. Then true is false, then negation value. Then true is false, then next value true is false, then next false is true, then next is true is false. Then third example is P or Q, P and Q or P and Q. Then PQ statement, then first the P or Q truth values, then last column P and Q or P and Q. The same statement P and Q. Then the truth value is write that, then P and Q truth value true, false, false, false. Then final column is P and Q or P and Q. Then P and Q true or true is true, false or false, false, false or false, false, false or false, false. Then next example D. Then the statement P or Q or negation P. Then P and Q truth value is right there. Then next find the value of P or Q. Then next value is negation P. Then the final column is the whole statement. Next example E, then PQ statement, then the statement is negation of negation P or negation Q. Then first find the value of negation P, next negation Q, then next negation P or negation Q, then the final value is negation of negation P or negation Q. Next we can see the F and C examples. The F example statement is P and Q. Then PQ truth values. Then first find the value Q and P, and the final column the whole statement P and Q. The last one example is the statement P or negation of P and Q. Then first write the value P and Q. Then next write the negation of P and Q. Next final column the whole statement P or negation of P and Q. These examples are the truth values of some statement. Next, conditional statement. If P and Q be any two statements, then the statement P to Q, this which is read as if P then Q, it is called the conditional statement. This conditional symbol is then arrow mark is used, then connective word arrow mark, then read as if then statement. Then also it is read as P only if Q Q. Then if P then Q statement, it is also read as P only if Q. Next one, thus or P implies Q, or P is sufficient for Q. Then it is also read as Q if P. The conditional P implies Q has two simple statements if P and Q connected by if then statement. The statement B is called the antecedent and the statement Q is called the consequent. Then if statement is antecedent and then statement is consequent, it is a conclusion value. Then next, truth table for conditional P implies Q. Then PQ truth value is right there. Then P2Q truth value, true is true, true false is false, false true is true, false is true. Then same truth value is true, and this true false is false, false true is true. Next one is biconditional statement. A statement of the form, then let it any two statements P and Q. This biconditional statement form is P if and only if. It is denoted by, then P is double side arrow mark, P if and only if Q. A biconditional statement contains the connective if and only if and has two conditions. If P and Q have the same truth values, then P if and only if Q is true. Then truth table for P if and only if Q, then PQ truth values right there. Then P if and only if Q is true is same truth value is true, different truth value is false. Then true, false is true, then true false is false, and false true is false. Next one is converse, inverse and contrapositive proportions. If conditional statement P implies Q. It is a conditional statement. Then converse definition is then Q implies P. Then given statement P implies Q, and then Q implies P is called the converse statement. Next, inverse statement, not P implies not Q. Then this symbol is a not P implies not Q. It is called the inverse proposition. Then third one is contrapositive. Contrapositive is then converse statement, then not of the converse statement. Not Q implies not P. It is called the contrapositive propositions. Well-formed formulas. The statement formula in which the order of finding the truth values are indicated by using parentheses is called a well-formed formula. It is used by parentheses. Example 1. Negation of P or Q. Then it is used by parentheses. It is called the well-formed formulas. Then example 2. P implies R and Q is not a well-formed. It is not used for parentheses. This proposition is not a well-formed formulas. Then but P implies R and Q. It is used by parentheses. Then other one is P implies R. It is used by parentheses. It is called the well-formed formulas. Tautology. A statement formula that is true for all possible values of its proportional variable is called a tautology. When all the truth values are true, it is called the proposition is a tautology proposition. Then example 1. P or Q if and only if Q or P. It is a tautology proposition. Then other one example. P or not P is a tautology. Then final truth value is a true. It is called the tautology statement. Contradiction. A statement formula that is always false is called a contradiction. Then final truth value is a false. It is called the contradiction statement. Example. P and negation P is a contradiction, or other name is a absurdity. Next definition is logical equivalence. Then take two propositions P and Q are said to be logically equivalent or simply equivalent. Then if P implies Q is a tautology. Then condition P implies Q is a tautology. It is called the P and Q are two statements are logically equivalent. Then example, not P and Q. Then one statement, other one statement, not P or not Q. These two statements are logically equivalent. Then final truth value is a, then two statements is true. It is called the tautology. So two statements are logically equivalent. The note P is equivalent to Q. It can be written as P if and only if Q. Then P imply P if and only if Q, writing these symbols. Next, the examples of using the connective words if and only if and implies. The first one is construct truth table for P implies Q and Q implies P. Then PQ, two statements. Then first and third column is P implies Q values. Next find the value Q implies P. Then last final column, P implies Q and Q implies P. Then PQ truth value is right there. Then P2Q true is true. Then true false is false. False true is true. Then false is true. Then next Q2 implies P value is true is true. Then true false is false. False true is false. False is true. Then P2Q and Q implies P. Then and truth value is true and true is true. False and true is false. True and false is false. True and true is true. Next example, construct the truth table for negation P and Q if and only if negation P or negation Q. Then PQ statement, first negation P, then negation Q, then P and Q, then negation P and Q, negation P or negation Q, then last the whole statement negation P and Q if and only if negation P or negation Q. Then first PQ truth value is right that negation P means not value, true is false, false is true. Then P and Q, then true and true is true. Then remaining all the truth value is false. Then next negation P and Q, true value is false, false is a true. Then negation P or negation Q, then false is false. Remaining other truth values are true. Then final column, then negation of P and Q if and only if negation P or negation Q, then all the truth value are true. Then in this statement, then truth values are, all the truth values are true. It is called, this statement is called the tautology statement. Next example, P and Q if and only if negation P or Q. This statement is check that true or false. Then P and Q truth values, then first P and Q values, next write the P or Q, then write the negation P or Q. This statement is a equivalent statement, check that. Then P and Q values true, false, negation P or Q values false, true. Then truth values are different, so this statement, these two statements are not equivalent. Laws of logic. Then 9 laws are given there. First law is a idempotent law. P or P, same statement, then and values, then P and P is equivalent to P. Then P or P, it is equivalent to P. Then commutative laws, P or Q equivalent to Q or P. Then P and Q equivalent to Q and P. Then associative law, P or Q or R, then equivalent to P or Q or R. Then take the three statements P, Q, R. Then first one is, then write the bracket in first two statement. Then other side, then bracket is used in last two statement. Then other one formula is and symbol. Then it is same for us. Next one is a distributive law. P, R, Q and R. Then in this law used by two operators and R. Then equivalent to P or Q and P or R. Then next formula, distributive law, other one formula, P and Q or R, which is equivalent to P and Q are P and R. Next law is a identity law. P or false is equivalent to P. P and true. P or true is equivalent to true. Then P and false, which is equivalent to false. P and T means true, which is equivalent to P. The next law is a complement laws. First one is P or negation P, which is equivalent to true. P and negation P, which is equivalent to false. Negation of negation P, which is equivalent to P. Negation true is equivalent to false. Negation false is equivalent to true. Next law is a De Morgan's laws. Negation of P or Q, which is equivalent to negation P and negation Q. Then one side is R symbol, other one side this AND symbol. Negation is multiplying inside of the statement. Then negation of P and Q, which is equivalent to negation P or negation Q. The next law is a absorption laws. P and P or Q, which is equivalent to P. Then P or P and Q, which is equivalent to P. Then next law is a conditional law. P implies Q, which is equivalent to negation P or Q. This is 9 laws of logic. Logical equivalences involving conditionals. P to Q, which is equivalent to negation P or Q. Then P implies Q, which is equivalent to other one formula, negation P implies negation Q. P or Q, which is equivalent to negation P implies Q. P and Q, which is equivalent to negation of P to negation Q. Negation of P to Q, which is equivalent to P and negation Q. First formula, P to Q and P to R, which is equivalent to P to Q and R. Then next one, P to R and Q to R. Then last statement is same, to R to R. Then first two statement write the, which is equivalent to P R Q to R. Then next one is P to Q or P to R. Then P2 is a same statement, then write P2, then remaining Q R R. Then last one is P2 R or Q2 R. Then last statement is same, to R, then P and Q to R. This logical equivalences involving the conditional symbols. Next one is a logical equivalences involving biconditionals. P if and only if Q, which is equivalent to P to Q and Q to P. Then P if and only if Q, which is equivalent to negation P if and only if negation Q. Then other next one is P if and only if Q, which is equivalent to P and Q or negation P and negation Q. Then last one is negation of P if and only if Q, which is equivalent to P if and only if negation Q. The duality principle, two statement formulas P P and P star are said to be duals of each other if either obtained from the other by replacing ant by R and R by ant. It is called the duality principle. Then example, P and Q are R. Then and is replaced by R is replaced by ant. Then P, R, Q and R. Then other one example, negation of P and Q. The negation of P or Q. This is a duality statement.